Okay, so maybe you've heard some bad things about the Half-Life quiz. It's not so bad. Um, what you should do is worksheet number 4 in the nuclear folder. Here it is. I am going to do 1, 2, and 3. 4 and 5 are just kind of repeats of a couple of 1, 2, and 3 here. So I'm only going to do the first 3. I'm going to shoot this video twice. I'm going to shoot this video once using this table and then once using the graph. I tried to do them both in the same video and it just didn't work. My brain couldn't handle it. So here we go. Number 1, let's look at that. Sodium 24. That's just what isotope we're talking about. That's not really important as far as what our answer is. So I could go ahead and get rid of, phosphorus 32 in this next problem and polonium 214. That's just telling us what isotope we're talking about. So anyway, before we even do number 1, there's some stuff that we can do on this table. For example, if we're talking about half-lives, and to make the most out of my table, I think I'm going to use this space right here. If we start off at no half-lives, that would be saying we had 100% of our original amount, whatever that was. And as a fraction, that would be 1 over 1. And then after 1 half-life, that would be 1/2 of it left. And that would be down to 50%. And so if we carry this on, we wind up with 1 over 1, 1 over 2, 1 over 4, 1 over 8, 1 over 16. I don't think I have any quizzes that go, or any questions that go up to 1/32, but I'll put it here anyway. And 100%, 50%, 25, 12 and a half, 6 1/4, and then what, 3 1/8. So if you're taking this quiz, these 3 columns right here are going to be the same every time. So if you can fill those in from memory, then that's probably a good thing, but it's not too hard to remember how to do that. I guess one key is that these 3 columns right here are going to change exponentially. In other words, every time they get cut in half. And then these 2 columns right here, they change linearly. In other words, we just count up half-lives and then time. That was something that I mentioned in a different video. But anyway, I promised to solve 1, 2, and 3, and I'm blabbing about a bunch of other stuff, so I better get to it. So let's look at this. The half-life is 15 hours. So I can go right over here and say, okay, so 0 half-lives, that's a time of 0. 1 half-life is 15 hours, 2 half-lives would be 30 hours, 3 half-lives would be 45 hours, and then just count by 15s. You get the picture. And then, how much sodium-24 will remain in an 18-gram sample? That is a real amount. So we're going to fill that in right here. So 18 grams. And if we cut that in half, we wind up with 9 grams, and then 4 1/2, and then 2 1/4, and then 1 1/8, and then I don't know, some, what's this, 0.625, like 5/8. So there we go. Now let's see how much will remain after 60 hours. So I guess I only needed to really go down this far. Oh, that's a terrible color for that, isn't it? I only needed to go down this far because after 60 hours, how much is left? The real amount is 1.125 grams. Okay, so let me clean up this table and I'll be right back. Okay, so now let's hit number 2 and see how that goes. After 42 days, okay, so that's going to be a time. A 2-gram sample, that sounds like an original amount, and it's gone down to 0.25 grams. So let's start with that. Let's fill in those things. So we've got 2 grams to start, and we wind up with 1/4 of a gram. So if my real original amount is 2 grams, if I cut that in half, I get 1 gram. And then 1/2 a gram, and then 1/4 of a gram. So this is the row that I'm interested in right here. I'm interested in this row. So what does it say? After 42 days. So that means that right here, this is 42 days. So it wants to know what's the half-life. In other words, what is this number right here? What is 1 half-life? That's what this question is asking. So how do we figure that out? Well, let's take a peek. If we say, all right, so if time was 0, and then we went 1, 2, 3 half-lives. If 3 half-lives is 42 days, so let me write that. 3 half-lives is 42 days. How do I figure out what 1 half-life is? Well, how do you get rid of a multiplied 3? You divide by 3. Whoops. You divide by 3. So if I divide this side by 3, it cancels out. And if I divide this side by 3, I get 14. So that means this column counts out by 14s. So 0, 14, 28, and then another 14 would be 42. So the question is asking, what is 1 half-life? 1 half-life is 14 days. Every 14 days, this stuff is half decayed into something else. Okay, 2 down, 1 to go. Let me clean up my table, and I'll be right back. All right, so this one. This one says it has, whatever it is, has a relatively short half-life of 164 seconds. That means that time here is going to count out by 164 seconds. So all I have to do is keep adding 164 to this all the way down. Okay, I confess, I just paused the video and used my calculator to add 164 every time. So anyway, it has a relatively short half-life of 164 seconds. How many seconds would it take for 8 grams? 8 grams is a real amount, so that's what I'm going to put right here. I've got my 8 grams. And each time this goes down, I'm just going to cut it in half. So 8 cut in half is 4, cut in half is 2, cut in half is 1, cut in half is a half, and then cut a half in half, and you wind up with 0.25. Okay, so the question says, how many seconds would it take for that to become 0.25 grams? So right here, 0.25, this is the one we're interested in. How many seconds? That's time. That's 820 seconds. So our answer there is 820 seconds. There you go. There's a 7.5-minute video on using this little table to solve half-life problems.